Lesson 6.4 from the algebra book is solving systems by multiplying first. So you've already solved systems with the elimination method, and I told you yesterday that now you're going to have to kind of work to get the elimination. So for example, we have the system 5x plus 2y equals 16 and 3x minus 4y equals 20. And again, these are two lines, and ultimately we want to know where do those lines intersect. Well, if I look here, 5x and 3x, they're not exactly the same or opposite. The same thing with 2y and a negative 4y. But if I look at these coefficients, 5 and 3, I know their least common multiple is 15. And if I look at the coefficients 2 and negative 4, their least common multiple is actually a 4. So I'm going to go with the one where I don't have to multiply as much. So if one of these coefficients is a multiple of the other, so 4 is a multiple of 2, then I'm going to go ahead and go with that. 5 is not a multiple of 3, and 3 is not a multiple of 5. So in order to get this 2y to become a 4y, I need to multiply the entire equation by 2. So I'm just going to tuck it underneath this other equation. You have to distribute all the way across the equation, including across the equal sign. So 2 times 5x is 10x, 2 times 2y is 2y, and 2 times 16 is 32. Oops. 2 times 2y is 4y, which of course was the point of doing this. So now I look, and I'm going to eliminate the y's, and they are exactly opposite. We have a minus 4y and a plus 4y, so I add them. So I end up getting 3x and 10x is 13x, 20 and 32 is 52, divide by 13, and x equals 4. Now just as we did before, we're going to put it back into the original. I like to put it in the top, so 5 times 4 plus 2y equals 16. So 20 plus 2y equals 16. Subtract 20, and 2y equals negative 4. Divide by the 2, and y equals negative 2. So your solution is 4, negative 2. So if you were to graph these, they'd cross at the point 4, negative 2. Let's try a few more. So here I look at 6x and 2x, 5y and 3y. 6 is a multiple of 2, so I'm going to go ahead and eliminate the x's. 6, in order to turn it into a 2, I can multiply by a 3. So again, I'll distribute, and I end up with a 6x plus 9y equals 15. And I'm going to rewrite the other one right underneath it. I will eliminate the x's. They're exactly the same, so I have to add the opposite. The x's have eliminated. 9y and negative 5y is 4y. 15 and negative 19 is negative 4. Divide by the 4, and y equals negative 1. Again, I'll put it back in the top. So 6x plus 5 times negative 1 equals 19. So 6x minus 5 equals 19. I'll add 5. 6x equals 24. I'll divide by 6, and x equals 4. So my answer here is 4, negative 1. Over here, 2 is not a multiple of 7, 7 is not a multiple of 2. 9 is not a multiple of 12, and 12 is not a multiple of 9. So what I'm going to do is I'm going to decide, do I want to eliminate the x's or the y's? I'm going to go ahead and eliminate the x's just because they have smaller numbers. So the least common multiple of 2 and 7 is a 14. So I will multiply this top equation by a 7 and this bottom equation by a 2. So now I have to distribute through both of them. If I distribute through the top, I get a 14x minus 63y equals 7. And through the bottom, I get a 14x minus 24y equals 46. And again, I have exact same, so I have to add the opposite. And I have negative 63y and a positive 24y, so that's going to end up giving me a negative, let's see, I think it's 39y, yep, equals negative 39. Divide by negative 39, and y equals positive 1. I'll put it into the top original, so 2x minus 9 times 1 equals 1. 2x minus 9 equals 1. I'll add 9. So 2x equals 10. Divide by 2, and x equals 5. So my solution here is 5, 1. Alright, let's try a couple more. We're going to just do lots and lots of these. I want you to get good at them. Alright, 7 and 8 are not multiples of each other, but 8 is a multiple of 2. So I'm going to multiply this bottom equation by 4 so I can eliminate the y's. That gives me a 32x minus 8y equals 20. I'll rewrite the other one so it's right underneath it. I have exact same terms, so I'll add. 32 and 7 ends up giving me a 39. X equals 23. I will divide by 39. So it looks like x equals 23/39, which is okay. I mean, it's not my ideal answer, but that's perfectly okay. We're going to substitute this in. So I'm going to have 7 times 23/39 plus 8y equals 3. This gives me, when I do 7 times 23/39, I get 4 and 5/39 plus 8y equals 3. I have to subtract off the 4 and 5/39. So when I do that, let's just write it up here so we can see it a little better. I end up with 8y equals negative 1 and 5/39 divide by 8, and I get negative 11/78. And there's nothing wrong with this. I did use my calculator, so I have 23/39 and negative 11/78. That would not be a fun one in my opinion to graph, but that's okay. Let's look at this one. 5 is not a multiple of 7, 7 is not a multiple of 5, neither are 8 and 3. So I want to choose which one to eliminate. It doesn't really matter. I'm going to go ahead and eliminate the first one. Least common multiple of 5 and 7 is 35, so I'll multiply this by 7 and this one by 5. This gives me 35x minus 56y equals negative 245. And I get a negative 35x minus 15y equals negative 110. I have exact opposites, so I'm going to go ahead and add. Negative 56 and 15 is negative 71y. Negative 245 and negative 110 is negative 355. Divide by negative 71. And I get 5. So I'll substitute in the top. 5x minus 8 times 5 equals negative 35. 5x minus 40 equals negative 35. Add the 40. I'll put it up here. I get 5x equals 5. Divide by 5 and x equals 1. So my answer is 1, 5. I have one last one for you, and it does involve an application problem. A sports equipment store is having a sale on soccer balls. A soccer coach purchases 10 soccer balls and 2 soccer ball bags for $155. So we've got, we'll say he purchases the balls and he purchases the bags. I'll just do G for bags since it ends with a G. And he purchases 2 of the balls and 2 of the ball bags, and that's $155. Another one purchases 12 of the balls. I don't know where I'm getting 2 up here. Make that a 10. 10 and 2. 12 of the balls and 3 of the bags, and the other coach spends $189. So ultimately they want the cost of the soccer ball and the soccer ball bag. So here 10 and 12 are not multiples, 2 and 3 are not. I think it's going to be quicker to eliminate the 2 and 3 because they're smaller. So I'm going to go ahead and multiply. They have a their least common multiple is 6, so I'll multiply this by 3 and this by 2. So when I distribute, I get a 30b plus 6g equals 465, and I get a 24b plus 6g equals 378. I have to add the opposite here. So that gives me 6b equals 87 divided by 6, and it's 1450. Ultimately we're looking for the cost. So a soccer ball is $14.50. Now I need to find the cost of the bag. So I'll go 10 times $14.50 plus 2 bags equals $155. So that gives me 145 plus 2 bags is 155. I'll subtract the 145. That gives me 2g equals 10 divided by 2, and g equals 5. So a soccer ball is $14.50 and the bag is $5. Alright, that is it for the notes on this. And your assignment, if you want to, well, you do need to get it started, is on the algebra book. It's lesson 6.4, and it's going to be page 396 to 397. I'm going to start you out with 4 to 16 even, and then we'll do some follow-up with it.